Hello students, in previous lecture we have solved the examples which is based on value of polynomials, remainder theorem and factor theorem. Then today we are going to learn about the factors of polynomials. All of you studied about that? Factors of polynomial. Then you can factorize different types of polynomials, that is factors of polynomials. Then see here, there are few algebraic expressions of which you can find out the factors. For example, if the polynomial which is in the form of a square minus b square, then you can factorize these into a plus b and a minus b. Then see here, a plus b, a minus b, those are the factors of a square minus b square of that algebraic expression. As well as there are a cube plus b cube. Then see here, it is one of the algebraic expression of which we can find out the factors, or we can factorize this algebraic expression. See here, the cube of first term plus cube of second term. Therefore here we can get the factors of that. Here a plus b in bracket, in another bracket see here a square minus ab plus b square. That means those are the factors of a cube plus b cube. As well as a cube minus b cube, we can factorize it into a minus b. That is one of the factor of this algebraic expression. As well as a square plus ab plus b square. Then we can also find out the factors of polynomial which is given in the form of ax square plus bx plus c. Then that is the quadratic polynomial. See here, it is a quadratic polynomial of which we can get the factors, and these type of examples we have solved in the previous standard. Let us remind factorization of that type of polynomial, that is quadratic polynomial, by solving few examples from practice set 3.6. Then here few examples which is given here, which is depends upon factors of that polynomial. Factors of polynomial. Then find the factors of following given polynomial. Then see here one of the example which is given, 2x square plus, that is 1x minus 1. Then see here, it is a ax square plus bx plus c type of polynomial, and we can factorize those polynomials like this. See here, it is a quadratic term of which coefficient is 2, and here the constant term is minus 1. Therefore first of all we have to multiply those both to get here 2 into minus 1, that is here we get minus 2. Then see here, we have to find out the factors of that minus 2, which is the addition of those two factors which gives the middle term. Then see here, minus 2, it can factorize into 2 into 1, and here as minus sign is there, therefore one of them is minus and one of the factor is plus. Therefore here minus 2 plus 1. Then see here, minus 2 plus 1, we get here minus 1, but the middle factor of which coefficient is plus 1 is there. Therefore we can change the sign, that is if we take that plus and if this factor, that is minus 1 is taken, then plus 2 minus 1, we get here 1, and that is the coefficient of middle term. Therefore, here we can write or expand that algebraic expression like this: 2x square, then see here plus 2 is there, therefore plus 2x, here minus 1x, then see here 2x minus 1x, that is 1x, that is the middle term. That means we can split that middle term like this and minus 1. Then from this we can get the common, that is here 2 and x is common, therefore 2x, in bracket only x is remaining there, plus 2x is taken out side the bracket, therefore 1 is remaining here, therefore x plus 1, in bracket here minus 1x minus 1, here common, that is minus 1, and therefore here minus 1 is common taken outside the bracket, therefore here x remaining there, and here minus 1 is taken outside, therefore here plus 1. Then see here x plus 1 is common, which is written only once, and in another bracket we have to write 2x minus 1, 2x minus 1. That are the factors of 2x square plus 1x minus 1. And that type of examples we have solved before that in previous standard. Let us solve one more example which is given in the practice set 3.6 in question number 1. Then that is root 3x square plus 4x, and here plus root 3 is given. Then see here the coefficient of that quadratic term is root 3. The coefficient of linear term is plus 4 and constant term is plus root 3. Then according to this concept, first of all we have to multiply root 3 into root 3. Therefore see here root 3 into root 3. Here we get root 9. Then that root 9 can be splitted into factors. Root 9 means that is 3, and 3 can be splitted into 2 factors. Then that factors, the sum of those 2 factors should be the coefficient of middle term. Then see here 3 into 1. Here plus 3 plus 1. Plus 3 into plus 1, that is plus 3. And here plus 3 plus 1, the addition of that is plus 4. And plus 4 is the coefficient of middle term. Therefore here we have to take the plus 3 and plus 1 as here factors of this polynomial. Therefore here root 3x square plus 3x plus 1x plus root 3. Then see here 4x, that is splitted into plus 3x plus 1x, that is 3x plus 1x 4x, and here the remaining terms is written as it is. Then see here there is root 3, that is a coefficient of first term, and root 3 is a constant term. Therefore we have to write that 3 and 1 in root form. Then 3 means it is a, see here 3 means root 9. Root 9 is equals to 3. Therefore here 3 is written in the form of root 9, or it is written in the form of root 3 into root 3. That means here therefore we have to write root 3x square plus, instead of 3 we have to write root 9x plus 1x plus root 3. Then see here root 3 is common in root 9. Root 9 means it is a root 3 into root 3. Therefore in root 9 root 3 is common. Here in those two terms root 3 is common. Therefore we have to that is taken common root 3 and x is there as well as x is there. Therefore, here root 3x is taken common and remaining x plus here from root 9 root 3 is taken outside. Therefore, and x is taken common. Therefore, only root 3 is remaining here. Therefore, x plus root 3 plus here no any common factor is there in those two terms. Therefore, whenever no any common factor is there, therefore 1 is common of those terms. Therefore, 1 is taken outside the bracket. Therefore, here remaining here x plus root 3. Then see here those two brackets are same. Therefore, here factors is x plus root 3, that is one of the factor, and here root 3x plus 1 is another factor. That are the factors of that given polynomial. Therefore, here the factor of this polynomial is x plus root 3 in another bracket root 3x plus 1. That are the factors of this quadratic polynomial. Then that type of examples we will solve from practice set 3.6. You should solve the remaining examples from practice set 3.6. Then we can solve few more examples which is depends upon factorization of polynomial. Then see here in question number 2, few examples are given here for factorization of polynomial. Therefore, here the example, one of the example which is given here, that is the second example, that is x minus 5 bracket square minus 5x minus 25, that is minus 24. Therefore, here the 5x minus 25, from this 5 is common factor which we have to taken outside the bracket. Therefore, x minus 5 bracket square minus 5 is common taken outside the bracket. Therefore, here remaining x minus from 25 5 is taken outside. Therefore, 5 is remaining there minus 24. Therefore, x minus 5 bracket square minus 5 in bracket x minus 5 minus 24. See here that polynomial is not in the form of ax square plus bx plus c form, that is quadratic polynomial, but we can convert this polynomial into quadratic form, that is ax square plus bx plus c form. Then see here, let us consider here minus 5 and x minus 5 same terms are there. Therefore, here we have to consider x minus 5 is equals to a, that is one of the new variable which is used for those same terms in this example. Therefore, this polynomial is converted into ax square plus bx plus c form. Then see here x minus 5, for this a is considered here. Therefore, this polynomial is converted into, see here, a square minus 5, here x minus 5 means a minus 5a minus 24, isn't it? Then see here, now this polynomial becomes like ax square plus bx plus c, and we have solved, or we have to factorize those quadratic polynomials like the steps which we have done in the while solving the examples from question number 1. Then we can factorize those by the same method, that is, see here the coefficient of first term is 1 and therefore here constant term is minus 24. Therefore, minus 24 into 1, that is minus 24, and that minus 24 can be factorized into 2 factors. To get the addition of those is minus 5, because minus 5 is the coefficient of middle term. Therefore, let us factorize this 24. See here, 12 into 2. But the difference in 12 and 2 is not the 5. Therefore, we can factorize it like this, 6 into 4. But the difference or addition of those two factors is not also 5. Therefore, here we can get the factors, another factors of these 24. All of you are aware of that? 24, the factors of 24 is 12, 2 or 6 and 4 or 8 and 3 are the factors of that's 24. Now the difference between these two is 5. Therefore, there is a possibility of those are the factors of that middle term. Therefore, here, see here, minus 24 is there. Therefore, one of the factor is negative while another is positive. Therefore, we have to taken 8 is positive and 3 is negative. Therefore, see here, 8 into minus 3, that is minus 24. But 8 minus 3, that is here we get plus 5. But here the coefficient of middle term is minus 5. Therefore, we have to change the signs of those two. If we taken minus 8 and plus 3, then see here, minus 8 into 3, minus 24 is there. But minus 8 plus 3, minus 5 is there, which is the coefficient of middle term. Therefore, we can write this. See here, 1a square minus 8a plus 3a minus 24. We have solved those type of examples before that in previous standard as well as from question number 1. Then see here, the common factor, that is between 1 and 8, no any common is there, but here 1 is common. Therefore, a square and a is common there. Therefore, here a is common taken here, a minus 8 plus here 3 in 24, 3 is there. Therefore, 3 is taken common. Therefore, a minus 8. And therefore, here a minus 8, a minus 8. Therefore, we can write a minus 8 in one of the bracket, or it is one of the factor of this polynomial, and the another polynomial, that is 1a plus 3. See here, 1a plus 3, that means a plus 3 is another factor. But those are not the factor of given polynomial in this example. Why? Because here we have considered x minus 5 is equals to a. Therefore, we have to put the value of, but here a is equals to x minus 5. Therefore, putting the value of a in this equation. Therefore, see here, a is x minus 5. Therefore, here in first bracket x minus 5 minus 8. In another bracket a is x minus 5. And here plus 3 is there. Therefore, simplifying this, here x minus 5 minus 8. Therefore, here we get minus 5 minus 8. Therefore, x minus 13. And here x minus 5 plus 3. Therefore, x minus 2. And that are the factors, that is x minus 13 and x minus 2 are the factors of that given polynomial, which is given in the second example in question number 2 from practice set 3.6. Let us solve few more examples like those examples from practice set 3.6. Then the one more example which is given here, that is x square minus 2x plus 3 plus 3. In another bracket, see here, x square minus 2x plus 5, and here minus 35. Then see here, in this example, in two different brackets, x square minus 2x, and here x square minus 2x are common. Therefore, here let us consider for x square minus 2x is equals to m. That is the another one of the variable. You may consider a, b, c, d or any alphabet letter instead of x, because the given original polynomial which is given in x a variable, therefore except x we can taken here any other variable. Therefore we have to put down the variable that is here for x square minus 2x, that is m. Therefore here that term is m plus 3, m plus 3. In another bracket, here x square minus 2x, that is m plus 5 minus 35. Then see here m plus 3 and m plus 5, those are two terms. Therefore we can get here the new quadratic term which is in the form of ax square plus bx plus c. Therefore here m plus 3 is a binomial and while m plus 5 is binomial, therefore here we get m into m, that is m square, m into 5, that is plus 5m, then plus 3 into m, that is plus 3m, plus 3 into plus 5, that is plus 15 minus 35. Therefore here we get the new term, that is new quadratic polynomial, that is m square plus 5m plus 3m, that is plus 8m plus 15 minus 35, therefore minus 20. Then see here m square plus 8m minus 20, that is the new quadratic polynomial which is in the form of ax square plus bx plus c. Then you have solved those type of examples by factorizing that polynomial. Then see here coefficient of quadratic term is 1, therefore here minus 20 is splitted into its factors, that we get the addition of those two factors is plus 8. Therefore here 4 into 5, 4 and 5, the addition or difference between those two is not the 8. Therefore here we have to factorize those into another factors. Then see here 2 into 10, then between 2 and 10 there is a difference is 8. Therefore there is the possibility of that middle term, factors of middle term is 2 and 10. Then see here minus sign is there, therefore one of them is negative. Therefore let us consider minus 2 plus 10, but minus 2 plus 10 is 8, that is plus 8. Therefore minus 2 and minus 10 are the factors of minus 20. Therefore as here coefficient is 1, therefore we can write the factors of that quadratic polynomial directly, like that. See here m minus 2 is one of the factor, while m plus 10 is another factor. Then that are the factors we get directly, because here coefficient of quadratic term is 1. If the coefficient of quadratic term is other than 1, then we cannot get the factors directly. But see here m minus 2 and m plus 10 are not the factors of this polynomial, because here variable is x and here we have considered the m variable for x square minus 2x, that term. Therefore here we have to put in the value of m, that is x square minus 2x here, and here we get the new factors, that is here, but here m is equals to x square minus 2x. Therefore, putting the value of m here, therefore here we get x square minus 2x minus 2. In another bracket, m, that is x square minus 2x plus 10. Then see here, that is here minus 2. If we factorize that minus 2, then if we get the addition of that is minus 2, then see here, first of all we have to split that minus 2 to get the addition of those two minus 2. But see here, 2 is factorized into 2 into 1 only. And then if we write the minus 2 here and plus 1, then minus 2 plus 1, that is minus 1, which is not the coefficient of middle term, as well as if we reverse that, plus 2 is taken and minus 1 is taken, then 2 minus 1, that is plus 1 is there. Therefore, plus 1 is also not the coefficient of middle term. Therefore, we cannot factorize this quadratic polynomial further. Therefore, we can't get the factors of that quadratic polynomial. See here, that is one of the quadratic polynomial which is in the form of x square plus bx plus c form. But this quadratic polynomial cannot be further factorized like that. See here, 10 is there and here coefficient is 1. Therefore, plus 10 can be factorized into two factors, that we get the addition of those two factors minus 2. Then we have to try for this. Then see here, 10 and 1 are one of the factor, but the difference between 10 and 1 is not the minus 2. Therefore, we have to avoid these factors, and one of the factor, that is 5 into 2. Then see here, difference between 5 and 2 is 3, not 2. Therefore, we can't get the addition or subtraction of those two is minus 2. Therefore, we can't trace those polynomials. Therefore, that are the factors of final factors of given polynomial, that is x square minus 2x plus 3, in another bracket x square minus 2x plus 5 minus 35, and that are the factors of given polynomial. One more type of example we have to solve from question number 2, which is given here, and then here the topic get completed. Then you may solve the remaining examples from practice set 3.6. Then see here, one of the example which is given here, that is y plus 2 in second bracket y minus 3, which is given here. In third bracket here y plus 8, and in fourth bracket here y plus 3 is there, and here plus 56. Then see here, there are 4 brackets here, and therefore here we have to rearrange those brackets to get those polynomial into x square plus bx plus c form. Therefore, see here, plus 2 minus 3 plus 8 and y plus 3 is there. Therefore, we have to rearrange those all like this, that the addition or subtraction of those constant term should become same. Therefore, see here, y plus 3 is there. Therefore, here y plus 2 and y plus 3, those are taken here, that is y plus 2 and y plus 3, and the remaining brackets, that is y minus 3 and y plus 8. Then now focus here, that is, see here, the addition of constant term, that is plus 2 plus 3 plus 5 is there. Here minus 3 plus 8, that is plus 5 is there. Therefore, there are the pairs of those two brackets here, we get the addition of constant term same. Therefore, we have to rearrange this, and therefore here we get y plus 2 in another bracket y plus 3, y minus 3 is taken here and y plus 8 is taken here. Then we have to multiply those brackets. Therefore here y plus 2 into y plus 3, therefore here y square, here plus 2y, then 3 into y, that is plus 3y, 3 into 2, that is 6 plus 6. Then similarly we can multiply those two binomial into binomial to get the quadratic polynomial, that is y into y, y square, minus 3 into y, minus 3y, 8 into y, that is plus 8y, then minus 3 into 8, that is minus 24, plus 56. Then see here we get y square plus 2y plus 3y, that is plus 5y, plus 6. Then see here y square minus 3y plus 8y, that is y square, here minus 3y plus 8y, that is plus 5y, minus 24. Outside the bracket plus 56 is there. Then see here there are now two brackets and two different polynomials we got here, which containing the common terms are there, y square plus 5y. Therefore let us consider the new variable, that is x is equals to y square plus 5y. For this term we have to consider x. Therefore putting the value for y square plus 5y is x. Therefore here x plus 6 in another bracket, y square plus 5y means x minus 24 plus 56 is there. Here we get the new brackets which are binomial into binomial. Therefore here we get that x plus 6 into x minus 24. Therefore here x into x, x square, plus 6x minus 24x, then minus 24 into plus 6, that is minus, see here 6 4s are 24, carry 2, 6 2s are 12, plus 2, that is 14, 144, plus 56. Then see here, focus here, and here we get the new quadratic equation by doing the addition and subtraction of like terms. Then see here x square, and here plus 6 minus 24 x. Therefore here we get, that is plus 6x minus 24x, that is here we get minus, that is 18x, 6 minus 24, that is here we get minus 18x, minus 144 plus 56. See here minus 144 plus 56. Then see here we can get 14 minus 6, that is 8, remaining one, that is 14 minus 6, here we get 8, and minus sign of the greater term. Therefore here we get minus 88, and now this polynomial becomes like the quadratic polynomial ax square plus bx plus c. Now we can factorize this polynomial by splitting that minus 88 into factors. Then see here 88 can be factorized into 11 into 8. Then see here the addition of those is 18, but see here if minus 11 is taken and plus 8 is taken here, then minus 11 plus 8, that is minus 3, but minus 3 is not the coefficient of middle term. Therefore, reversing the sign, plus 11 and minus 8 is taken. Then here we get plus 3. But plus 3 is not the coefficient of middle term. Therefore, we have to find out another factors of 88. Then here we can get the factors of, that is here 22 into 4. Then difference between 22 and 4 is also 18. Then here minus sign is there, therefore minus 22 and plus 4 is taken. Then see here minus 22 plus 4, that is minus 18. Therefore we can split this polynomial, or we can get here coefficient of this quadratic term is 1. Therefore here we get the factors directly, that is x minus 22 and in another bracket x plus 4. And here, but here the value of x is equals to, see here, y square plus 5y, that is y square plus 5y. Putting the value of x here, therefore here we get the new quadratic polynomial, that is y square plus 5y minus 22 in another bracket y square plus 5y plus 4. Then see here, now those are the new quadratic polynomial. Therefore we have to try to factorize those. Then see here minus 22, the factors of 22 is 11 and 2 only, because those are prime numbers. Therefore here difference between 11 and 2 is not the 5. And one more factor, that is 22 and 1, and difference between 22 and 1 is not 5. Therefore we cannot factorize this quadratic polynomial further. It remains as it is. But see here, plus 4 is there. Plus 4 can be split into 4 into 1. And here plus 5 coefficient of middle term. Therefore plus 4 plus 1, that is here we get plus 5. Therefore we can factorize this quadratic polynomial only. Therefore here we get the factors of those two directly, that is y plus 4 and y plus 1. Y plus 1. Those are the factors of this quadratic polynomial, and this quadratic polynomial cannot be further factorized, that is y square plus 5y minus 22. That are the three factors we got here of the factors of the given polynomial. That is about the few examples which is given in the practice set 3.6, which is based on factors of polynomial. You should solve the remaining examples from practice set 3.6. Here topic get completed and you should solve all practice set given in this chapter. Thank you.